In lesson 66, we'll be working with signs of fractions and 30, 60, 90 triangles. The first part of this lesson will be working with signs of fractions, and something to think about first before we talk about this is just where you can put that negative sign. And for example, if you had x over x and you wanted to say that that fraction was negative, you could just put a negative out in front of it. Another way to write it is a negative x in the numerator and a positive x in the denominator. And then still another way to write that is a positive x in the numerator and a negative x in the denominator. All of those mean that fraction is negative. So apply that to simplifying practice problem A. On the right side you have a negative a plus 2, so let's go ahead and factor that negative a out of the bottom, and so we'll have 1 over a minus 4, and then let's say plus a negative 3b over negative times a minus 2. And now we see that we have negative over negative, so we could just make that positive. And so we have 1 over a minus 4 plus 3b over a minus 2. And now we could just add those two. If we get common denominators, that means on the left we'd multiply by a minus 2 over a minus 2, and on the right by a minus 4 over a minus 4. And so these problems, they're called contrived problems. They're just designed to help you work with your negative numbers. And a lot of times when we want to simplify something, it's just good to have the variables as positive values when we see that we have sums in the denominator like that. So that's what we did there. We factored a negative 1 out of the denominator on the right, and that made our variable a positive value. So now we'll just end up with a minus 2 and then plus 3b times a, so that'd be 3ab, and then 3b times negative 4, or minus 12b. And then all of that will just be over a minus 4 times a minus 2. Look at practice problem B. Let's add those two fractions together. Well, look at the denominators, x plus 5 and minus x minus 5. Now if we factored a negative out on the right, we'd end up with a minus times x plus 5. And so we could get an x plus 5 for both denominators. So let's go ahead and do that. X plus 7 over x plus 5, and then we'll say plus, and let's move the negative up to the numerator. Remember, we can do that. We just talked about how you can do that. It still makes the whole thing negative, minus 4x plus 7 over x plus 5. So what we did there was we factored in a negative out of the denominator, and that gave us a negative x plus 5, and we just moved the negative up to the numerator. And so now we have common denominators. Let's add those two, and let's say x plus 7 minus 4x minus 7. And so the 7's cancel, and we end up with negative 3x over x plus 5. Or we could write it like this as well, negative 3x over x plus 5. Either way is correct. The negative sign's out front. That means we could put it with the numerator or the denominator. Doesn't matter. And so like I said earlier, these problems are contrived problems. They're designed so that you have to factor a negative sign out of the denominator. And like that highlighted negative x minus 5, we could recognize there that if we factored that out, we would get common denominators, and we could simplify that fraction pretty quickly. So when you see that, when you see like a negative variable in the denominator, when you have a sum like that, just think, well, what would happen if I factored that out? Would that help me simplify this? And then go ahead and do the problem. Part B of this lesson is on 30, 60, 90 triangles, and that's just a common right triangle that you see a lot when you're working with trigonometry. Now there are an infinite number of 30, 60, 90 triangles, but their sides are always the same proportion. And so one of those 30, 60, 90 triangles has an opposite side of 1, an adjacent side of the square root of 3, and a hypotenuse of 2. And so sine of 30 is equal to opposite over hypotenuse, or 1/2. Cosine of 30, that equals adjacent over hypotenuse, or square root of 3 over 2. Tangent 30, that's equal to opposite over adjacent, which is 1 over the square root of 3, or square root of 3 over 3, if we want to write that with the denominator rationalized. Now let's talk about the 60-degree angle. Sine of 60, that's equal to opposite over hypotenuse, which is square root of 3 over 2. Cosine 60, that's equal to adjacent over hypotenuse, or 1/2. And then tangent of 60, that's equal to opposite over adjacent, which would just be square root of 3. Of course, you can always figure out those sine, cosine, tangent of 30 on your calculator, but sometimes it's easier just to know those. It makes the problem, or working with a problem, a lot quicker. For example, if you had this problem right here and you wanted to figure out what a and x were, you could use those ratios that you know about off that 30, 60, 90 triangle that we have drawn at the top. And for example, if you wanted to figure out x, you could think, well, tangent of x, that equals opposite over, or tangent of 30 equals opposite over adjacent, 7 over x. And then think about your 30, 60, 90 triangle. Tangent of 30 for that is square root of 3 over 3. And then you can just cross multiply, and you'd say 21 is equal to square root of 3x. And so x would be 21 over the square root of 3, or if we want to write that with a rationalized denominator, we would say x is equal to 21 times the square root of 3 over 3. And then if you want to figure out a, well, you say, you know the opposite over hypotenuse, that would be sine of 30. And so you could say sine of 30 is 1/2 is equal to opposite, which is 7 over hypotenuse, which is a. Cross multiply and you get a equals 14. And so there are your two answers. And so one way you can use the 30, 60, 90 triangle is as a similar triangle to a problem you're trying to solve. Now you don't have to do them that way. We could have just figured that out using our calculator. But you use those a lot, so it's a good idea to memorize what sine, cosine, tangent of 30 are, sine, cosine, tangent of 60 are, and you can use those ratios to help you more quickly go through a problem. Also, if you do it this way, like for x, that was going to be an irrational answer, 21 times square root of 3 over 3, and so we would have had to round that. The way we have it now, that's a more accurate way of writing the answer. We don't have any decimals to round. And actually, I should have simplified that to 7 times the square root of 3 instead of leaving it like it was. Let me show you one more trick with similar triangles like this and a 30, 60, 90 triangle. This is just another way to solve the problem we just did. I've got the 1 and the 7 highlighted in those two triangles. So the top one is like our base 30, 60, 90, and so that bottom one, if those two sides, those are similar sides, and so we would just multiply by a factor of 7 there, and then that means x would be 7 times the square root of 3, and a would be 7 times 2. So that's another way to do these 30, 60, 90s. If you have that side opposite the 30, since on that base one it's just a 1, whatever it ends up being in the unknown or the triangle you're trying to solve for, if that side is given like it was here, you can just multiply everything else by that multiple. And you can get the answer that way as well. So there's a lot of different ways to solve a 30, 60, 90 triangle. You can just use your calculator and solve using your trig functions that way. Memorize the ratios, and either way you should memorize these ratios because eventually it will make your problems a lot quicker to do. Memorize the ratios for sine, cosine and tangent of the 30 and 60 degree angles of a 30, 60, 90 triangle. Okay, well that's all for lesson 66.